Alright, what's up guys? I got a midterm tomorrow and I'm out here recording this video. So much to study for. I don't want to do any of it. But what are you gonna do? Alright, so gotta make the Pokemon sound of the day. That Pokemon today is Doug Trio. Let's take a listen, shall we? Trio. All right, Leetcode of the day. Let's see what we got. Most beautiful item for each query. Okay. Huh. You want to give it a 2D integer array items, where items at spot I is the price and the beauty of that item. For each query's J, you want to determine the maximum beauty of an item whose price is less than or equal to queries at spot J. Okay. Can I reuse items? The query is 6. So is it the price? What is the query is? Huh? They all have a price of 1. Note that multiple items can have the same price and or beauty. Okay. Is this just binary search? I don't want to look at the topics, but I'm feeling binary search right now. Like I get the query, it's 1. Okay. I look for a price. I look for 1. Oh, but then the beauty. Hold on, let me think. What is this? No. Because the thing is, a lot of the items could just be useless. Like this. These 2 items, all these 3 items are just, there's no point. Can you do the same one? I mean, here's my idea, okay? Here's what I got cooking in my brain right now. What? Why did this also restart? So annoying. Okay, so let me take this right here. I make this like query array, or I make this like array. Oh boy. This array, and every single index, right, is going to equal like the max beauty at that price. So if your price is 0, the max beauty is 0. Okay, So this is 0, 1, 2, 3, 4. So this one goes up to the array is gonna have, it's gonna, maybe not the index. Maybe it should just be a 2D array then. Wait, that's just gonna solve the problem. Hold on, let me. Because like basically, what I want to do is I want to have this 3, right? And then I look in this array, and then I see like, oh, 3. At spot 3, the max beauty is 4, for example. So I need to make this array. Whoops. What I was thinking is I just have a maybe like a max. Like instead of this I have a. Well, the price 0, it's 0. Maybe I remake a 2D array. And then here at price 1, it's 2. So 1, 2, right? Now we go to 2. At 2, it's 4, right? So 4 right here. Do smaller. And now when we go to 3, guys, this is where the algorithm takes over. Oh, I guess it's, so we have 5. Our potential choices for this spot are either this 2, this 5, and this 4, right? So we just take the max of that, which would be 5 for this one. And then at 4, we're looking for our options are either 5 or that's it. So this is 5. And then this is 5, which is 6. Let's see right there. And this is great. This is the array we want. And I think this is an n log n. Like I just sort this based off this first input, and then I get this array. The issue is that like if I query 6, how do I query 6? Well, if it's larger, then I just get the biggest one no matter what. Right? But I think I would want a spot for each of them. So then each query is O of 1. So then this whole thing is n log n. Like if they were like 4 was missing, for example, I filled it in. So the space is the length of input items. And then it's just good. And that's just a good way to solve the problem. Now guys. I don't remember how to sort Python list based off first value in list. Here we go. Just make sure that works. 1, 2, 3, 3, 5. Yeah, it did work. Okay. What is print max items? Do I do this? Is that how it works? 2. Well, that's not right. 5, 6, 1, 4. Oh, no, that's right. Hold on, let me change this. Instead of 5, I'm going to make this 2. I just got to make sure this is doing what I think it's doing. 3, 5. It is doing what I think it's doing. Wait, it's sorted. I can just get print max at spot -1 spot 0. What am I doing? I can just do that. Whoops. Not items. Not max. 5, 1, 10. That's right. 3. Yeah. Okay. And then check this out, right? So, I mean, I guess I'll just call it DP. I don't know if DP is a good name for it, but 4i in range 0. Hold on. Should I put this in a heap? Should I even do this? Hold on, guys. I know I can solve this quickly, like in a good way. This is just kind of tripping me up a little bit how I want to go about solving this. I can make this O of N. I don't need this. Hold on. Stop. Okay, instead of doing it like that, I'm going to do a... Hold on. Let's get rid of all this. I'm going to make a dictionary. For PB in items, if P not in hashy at spot P equals B. Else, if B is greater than hashy at spot P, hashy at spot P equals B. Yeah? Amazing. Okay. For I in range 0 to the max of items. Wait. At spot 0. Hold on, guys. I just forgot how I did it. Two. Yeah, well, that's not right, is it? It needs to be 5. How is it 2? What if it's just max of items? Five, 6. Spot 0. 5, 1, 10. I'm pretty sure that's right. Okay. Now I'm going to want to fill up this DP array. Right? Yeah. Okay, DP at spot I is equal to the max of DP at spot I minus 1 and hashy at spot items. Wait. At spot I, oh my god. Spot 0. Yeah, that's super readable. That's readable, bro. That's actually readable. Oh, DP. Oh, you have to append. Let's try that. Can only concatenate list. Oh yeah. Always forget. How is this out of range? It should this loop should run 10 times in this example. DP at spot I equals max. Wait, 10 to the 9th? Oh, this is low-key a terrible idea. Damn, 5K? It's kind of wild. Wait, this is a terrible idea. Yeah, screw this, bro. What am I doing? Okay. Yeah, no, that's terrible because it's 10 to the 9th. That means my array is going to be like a billion. Yeah, okay. No, so we have this hash map and this is all we need. Okay, this is all we need. Can I return this in any? Queries isn't sorted, right? Can I sort it? How much time? 20 minutes. Oh, so it's got to be in order, huh? If queries is sorted, it's easy, but man, I want to see if I run out of memory. Okay, I'm gonna try the solution still. Dude, what? Oh yeah, of course that doesn't work. What am I, stupid? Oh, and this is, it doesn't know if it's in there. Wait, list index out of range? Dude, what? On if. Bro, why? Oh yeah, obviously that doesn't work. Oh, it's just I. It's not hashy, it's just I. Why are these empty? Zero, 1, 2, 3, 4, 5. Hold on. Should be 5 though. This +1 doesn't need to be here. But this shouldn't be 0. This should be 5. Is this not going long enough? Yeah. 1, 2, 3, 4, 5. 1, 2, 3. Okay. For Q in queries. Is it Q? Oh, if. Is it spot Q? Let's take a look here. 1. Yeah, it is. Okay. What? 1, 2, 3, 4, 5. Uh-huh. One, two, three, four. That's not. Huh? Why is it only going 4 times? Wait, what? +1 and +1. So maybe +2. Huh. Oh, there we go. All right. I think this is going to run out of memory, though. But let's just see what happens. Yeah. That's pretty funny. It's not funny. It's not funny. It's not funny. It's not funny. Okay, we got to redo it. Not cool. Not cool. Okay. I really want to say this is binary search. Like if when I take, hold on. Like I'm going to take this array here. It needs to be sorted. 1, 2, 2, 4. Oh, but there's, okay. Then when there's a duplicate, you just take the max. Pretty obvious. 3, 5. But this, there's no 4. So you just, there's nothing here. Five, 6. So the array is gonna look like this. Okay. Oops. And when I query 4, how is it gonna? Like it's somewhere here, a binary search, and I just get to here. I get to 3. I mean, yeah, I get to 3 and I just return whatever's at 3. Because it's going to be the max no matter what, guaranteed by my hash map. So let me take this array. I guess I could make the set too, but like if p not in dupe r dot append p dupe dot add p and then r dot sort and r. Maybe it's in hashy already. If p not in hashy, let's do that. We can just reuse the hash map here. There we go. And now I can just run binary search. Like I can find 4 and I just take the smallest one and then it's all good. Yeah. Okay. So let's do a helper function up here. We'll define the binary search up here. So def binary search. I mean, I only have the num I'm looking for. LR equals. If r spot m is less than num, it means we got to move the left pointer. L equals m plus 1 equals m minus 1. And then if that happens, you just return m. Oh, I gotta print r as well. Did I not? Is that not right? 2, 4, 5, 6. Oh, we got 3 6s here. Why is it? Wait. But 5 is in there though. Hold on. Okay, 35 minutes. Just chill on me, guys. Just chill on me. We're gonna solve it. 1, 2. No. Something's wrong with this binary. When I'm returning M here, this is the problem. Like what I'm finding when the query's 3, no problem. 3, 5, that's great. But when the query is 4, this needs to be returning not that. And that's the problem. It's like if R at spot M is greater than num, then M minus equals, or it's like while, some shit like that. I don't know. And it's out of range. Who would have guessed? Key error 0. Why are these 5s, bro? Because that's why. No, it is working though. It's just this needs to be sorted before I go through it. This right here. Okay. 3 is 5. Bro, I just fought for my life on this problem. I just fought for my life on this problem, dude. I'm not even drilling. No. Beauty cannot be defined like this. It is subjective. Okay. Points on a plane? Heap makes things easier. Oh, does it? Was it binary search? I did binary search on this. Let's see what was going on. Binary search. I figured out the binary search solution. So, sorting, binary search, it's fucking... This code is super messy. Let's just see how Leetcode did it, because that's my goat, so... There it is. First video. Take a look. How to quit YouTube addiction. Check that out. 17 minutes? This guy's tripping.
Hey everyone, welcome back, and let's write some more Leetcode today. So today let's solve the problem, most beautiful item for each query. Let's solve this one systematically. I'll show you two approaches. One is brute force, and another is then optimized. And luckily, we can actually arrive at the optimized approach just by making some relatively small modifications to the brute force one. Not necessarily saying that this is easy to come up with or easy to solve, but this process itself is straightforward for this problem. There's no like fancy tricks involved. The problem description is a bit abstract, so I would recommend really focusing on the example. The idea is that we are given a list of items. You can see each item is a pair of values. The first value represents the price of that item, and the second value represents the beauty of that item. I'm just going to represent these as characters because we really don't need to know the meaning behind these things. Now, the queries array, each of these queries represents a price. So once again, just to keep things simple, I'm going to replace it with a P. We want to answer each of these queries. So thus, we're going to end up with an output array that's the same size as the queries array. How exactly do we answer a query? Well, this one means that among all of the items, we only want to consider the items that have a price less than or equal to 1. So based on that, we could scan through the entire list of items, and anytime we see an item with a price greater than 1, just ignore it. So pretty much ignore all of these. So this is the only item we consider. It makes our life pretty easy, at least for the first query, because what we would want to do is among all of the remaining queries at this point is just get the maximum beauty. So in this case, it's easy.
My nose
we just
looks kind
have
of
2,
long.
so that's how we answer the first query. I'm going to put a little 2 over here. Second query, same thing. Only consider the items that have a price less than or equal to 2. So we skip all of these, only considering these two. Which one of them had the maximum beauty? It was this one, and the beauty is 4. So put 4 in here. That's it. That's how to solve the problem. At least the brute force was pretty easy. You could say the time complexity is n, where that's the size of this array, times m, where that's the size of this array. Pretty straightforward approach. I'm going to leave this as is because I want to quickly code this one up, even though it's pretty trivial, because that's going to help us arrive at the optimal solution. That's a little tip I would give you if you had trouble coming up with the optimal solution. Did you at least code up the brute force? Because if you didn't, well, what were you spending your time doing? Maybe if you are already making progress on the problem, that's okay. Then you can skip the brute force. But if not, you really want to build those problem-solving skills up. So I'm going to create an array. I'm going to initialize it to be empty. We could make it the same size as the queries array, but I'm going to answer these queries from left to right anyway, so it doesn't really matter. I'm going to do this, and then I'm going to do this for every query, just going left to right. Now, how do I answer the current query? Well, what we want to do is determine the max beauty. So I'm going to create a little variable called max beauty. We're guaranteed, I think, that everything in both arrays is going to be positive. So setting it to 0 initially is fine because we're trying to maximize it. We initialize it with a small value. Now I'm going to go through all the items. Remember that they are pairs, so we can unpack them like this, little Python tip. If you're new to Python, on Leetcode.io, there's a few Python courses. Specifically, the one for coding interviews is what I would recommend. For each of these items, remember, we only want to consider specific ones. So we add a conditional statement to filter them. So we want the price to be less than or equal to the query price, so less than or equal to Q. And if that's the case, in here, we can maximize the beauty. So we can say max beauty is going to be max of itself as well as the beauty of the current item. And if you want to, you could simplify this code into like a ternary operator. I'm not going to do that. This is a brute force solution. Who cares? After that, we will append to the result the max beauty. And I guess it's worth mentioning now that it's actually possible. What if none of the items had a price less than or equal to Q? Well, what they want us to do in that case is answer the query with a default value of 0. So that's another reason why I initialized this to 0.
Same.
So this is the brute force solution. Running it here on the left, you can see that it definitely is not efficient. So let's optimize it. They gave us a pretty nice hint with this problem. First of all, when we have a particular query given to us, let's say it's 4, wouldn't it be nice if the input array was already sorted? Because remember, what we're trying to do with this query is we only want to look at the queries that have a price less than or equal to 4, right? So without organizing this data in a smart way, just by like throwing it into an array that's not sorted, we have to scan through the entire thing. That's where the inefficiency comes from. I mean, we're definitely going to have to scan through this entire array just to answer each query.
Yeah.
But how fast can we answer each query? Well, if we do some pre-processing, we can actually get the time down to constant. For an individual query, amortized at least, we can get it to constant time. Amortized is similar to like average for those of you who don't know what it is. So we are going to take this and sort it. So let me redraw this as a sorted array. Okay, so now this is sorted, and I should specify that it's specifically sorted based on the price, not based on the beauty, because that's how we're going to make these queries more efficient. But you'll notice that actually, just by guaranteeing that this array is sorted, that's not enough. The hint that they gave us in this problem is they actually gave us the queries array pre-sorted. That's not guaranteed. So we are actually going to have to sort this as well.
I literally tried to look for that, and I could not find that in the directions. Where does it say that? Where's the hint that it's sorted? It never says it's sorted. Kappa. No, it doesn't.
Now, in this case, it's not going to change, but again, the time complexity from sorting this is going to be n log n, and this is going to be, let's say, m log m, which each of these is technically still better than n times m, at least in most cases. I mean, you can imagine there might be a case where this would be bigger than that, but generally speaking. Now, I know a lot of you are going to ask, how did you know you have to sort this array too? Like, how could you have figured that out? Well, let me show you.
Oh, I didn't sort that queries array. I don't think I did that. Did I? No. No, I did not. Oh, it's the heaters problem. You could have done it like that too.
Assuming, let's say, these were not sorted, and we only sorted this. First of all, I think there is some obvious intuition of why sorting might help, but how do we actually make a working solution out of it? Let's try to do it and then see what goes wrong. I have a 4. Okay, so I'm going to scan from left to right, and I'm going to stop as soon as I find a price that is higher than 4, because I know that I don't have to consider this guy, and I don't have to consider anybody to the right of this guy either. This seems like an optimization, but still, in the worst case, I mean, we still might have to iterate over the entire array. Like if I did that for 4, okay, now maybe I'm gonna have to answer this query next too, and I'm gonna have to like iterate over, and this time I get to stop a little bit earlier. I get to stop over here, and I don't have to traverse this part of the array, but still this might be proportional to n, so the time complexity still might be n times m for this solution in the worst case. But notice something, repeated work. I scanned here, left to right, and now I'm scanning here, left to right. What determines the ending position of a query? Well, literally the value of the query determines the ending position. 4 is going to end over here, and 2 is definitely going to end earlier. I mean, theoretically, some queries might end at the same spot, even if the values of those queries are different. 4 and 3, for example, are both going to end at the same spot, but still, I would definitely want to answer the 3 query before I answer the 4 query, because the for query can actually be answered more easily if we've already answered that other query, because we already did all this work. We already found the max possible beauty where the price is less than or equal to 3. So now I only have to scan through the items that have a price exactly equal to 4. If any of them exist, in this case they don't, and if they did exist, I would have found the max of them. Now, that max wouldn't necessarily have been greater than the max where the price was less than 3. So I can take the max of this and the max of this, and the good thing is the max of this was already computed. It would have been stored somewhere in this array. So that's the idea behind this problem. That's the intuition behind this problem. The solution I'm about to show you based on that intuition, after the sorting is done, the time complexity is actually just going to be n plus m. And then including the sorting as well, we get n log n plus m log m. So now let's get into the solution. It's going to be a little bit tricky because
I did this very differently
what if we
than this
sort
guy.
this array? We still wanted like the original value. If the last value is 6, we want the answer to that query to be over here. So the easy thing I'm going to do in Python is actually convert this into an array of pairs where I'm going to have the index, or actually the index is going to go second. I'm going to have the query value first, q, and then the second value is going to be the index, the original index of that query. This one is 0, 1, 2, 3, etc. Now this array is already sorted, but imagine if it wasn't already sorted. Actually, don't even imagine that because I'm just going to go ahead and draw it as an unsorted array. Well, there's no point in me drawing it as an unsorted array, but let me just say that the original index of this was 0, the original index of this was 1, this was 2, this was 3, and let's say this was 4, and this was 5. So now the idea is that we're going to have 2 pointers. Let's say I have the I pointer, which tells me which query I'm currently answering, and I have a J pointer, which tells me which item I am currently at. So I'm going to start at the beginning because remember, these are both sorted. Now I have my I pointer.
I don't know. Binary search is still a little bit more natural to me.
I want to go through all items that have a price less than or equal to 1. It looks like the first one does, so I'm going to visit it. Okay, I'm going to get the beauty of it. It's 2, so that's the max beauty so far. And now I'm going to increment J over here. So now we're done. The price is greater than 1. We can't really go any further. No need to do that. So the max beauty that we found, I'm going to store that in a variable, by the way, just calling it max for now, is 2. So the answer to this query that happens to be at index 0 is 2. Now, one guarantee I have is that every single one of these queries is going to have a value greater than or equal to 2.
Yeah, so you don't move the J pointer.
By definition, because remember what the meaning of a query is. We're looking for all items now that have a price less than or equal to 2. The key word is less than. This is technically included. Like this is a part of the solution set for this. That's how we're eliminating the repeated work. So now we're going to look at the current item, the price less than or equal to 2. Okay, the beauty of it is 4. We can update our max safely. It will now be 4. And then we will shift J pointer over here. Okay, now the price is too big, but the max we found was 4. Let's put that in index 1. It's going to be over here. Okay, now we're at 3. And I probably should have drawn this I pointer shifted, but I think you guys get the idea. So 3 now. Okay, beauty is 2. Don't update the max. J pointer is going to go here. Price is still less than or equal to 3. Value is 5. Update the max. Shift J again. Now it looks like we've gone a little bit too far. So we can stop and we will put 5 in index 4 this time because that was the original index of 3. Index 4 would be 2, 3, 4. Okay, putting it here. By the way, I just chose these indexes arbitrarily if you're wondering where I got these from. So now shifting I pointer here, we're at 4. Is the price of this less than or equal to 4? No. So what does that tell us? It might seem like we didn't find any valid items, but no. All the previous items technically are also associated with 4. And we already found the max beauty among all of them. It's 5. It's in the current variable we're keeping track of. So the answer to this query is going to be this variable, which is 5. So at index 5, we will put the value 5. Now I want to answer this query. That's where my I pointer is at now. Is the current item less than or equal to 5? Yes. So now our max beauty is going to be 6. I'm really sorry that this is getting kind of sloppy. And now we can shift our J pointer out of bounds. So J will be over here now. So since it's out of bounds, we don't really have any items left. So our max is now 6. And that's what we're going to put in index 3 now. So put that 6 there. We will shift the I pointer. Just because j is out of bounds doesn't mean we stop answering the queries, because we have to answer all of these. So now I'm going to have my I pointer here, 6. We're out of bounds, no items to look at anyway, but that's okay because our max tells us the answer to this query anyway. So 6 is what we're going to put in index 2. This would be
that's why I didn't sort it. This is the reason I did not sort it, because the queries like get screwed up with the res or with the result array. That's why I didn't do it.
solution for this example.
How did you do
Let's
this?
code
though?
it up now.
Yeah, how did
We
you
want
code
to
that part
sort
up?
the 2 input arrays. We can just take items and sort it by default, because in Python this will sort this in place. And since this is a tuple, we know that that tuple represents like the price and the beauty. It will sort it based on the first value in that tuple. It's not a tuple, it's an array, but it's just a pair. For the queries array, it's a little bit more complicated. So I want to reassign the queries array to this. I want to build a new array, first of all. It's going to be an array of pairs. This is list comprehension in Python. I would check out my Python for Coding Interviews course. It has some interactive lessons where you can practice implementing this yourself if you're new to it. But we can do this in enumerate queries. This will give us the index query pair from the queries array. We will create a pair, putting the query first. We're doing that intentionally because when we sort this thing, we want to sort it based on the query, the first in that pair. We could do that on a second line, but you could also just wrap this in a sorted. That will actually create a sorted copy of this array. And then we're taking that and reassigning it to this. Now we want to go through every query and answer it. So we could say for q in queries, but don't forget, we just made that an array of pairs. So we're going to say for qi in queries. We want to keep track of the maximum beauty. We could declare that inside, but we are going to need the maximum beauty from the previous ones that we answer. So I'm actually going to put that outside. I'm going to put that up above the loop. Over here, inside of the loop, I want to have a pointer that points to the items array. So I'm going to actually call that j. J is going to be equal to 0. While that j pointer is in bounds, while it's less than the items array, I want to find all items that have a price less than the current query price. So I could say items at index j. I want the first of that pair. I want the price. So I'm going to do 0
heater,
while that's less than or equal, I guess, to the query price. This item is
max
valid.
b equals max.
So what do we want to do
item
with
spot j
valid
spot
items? We want to find the max
0.
beauty among them. So we do this max, the max beauty, and items at I1, j. And we will also want to increment the j pointer by 1. After this loop is done, we can assume that we have the max beauty in this variable. Maybe this loop didn't run at all. That's why we put this variable out here, because then at least we'll have the max beauty from all the previous queries. Either way, down here, we want to then take the max beauty and add it to the array. We can't do this. We can't say result.append
you got to do it at the
max
spot.
beauty, not only because I didn't declare the result array, I'll do that now, but also because now we're answering these queries technically in sorted order, but we're not answering them in the order that they were originally given. So that's going to complicate things. So now I'm going to initialize the array like this with all zeros. It's going to be the same length as the queries array. And now we're going to populate the result like this. Result at index I. Index I is the one that represents the current query, and there. This I comes from the original query, which we populated up here. So that's the whole code. Let's go ahead and return the result, hoping I don't have any bugs. And on the left, you can see that it works. It's pretty efficient. This is the most optimal solution. For some reason, I still see comments referring to the Leetcode runtimes. Please, guys, don't pay attention to these. You're wasting your life. They're not important, and I feel like it's pretty obvious, but for some reason, some people, it's not. Thanks for watching, and I'll see you soon.
All right, let's just get started on the project. Oh, we're done with the music player. We're actually on the Sudoku solver, guys. Okay. Give me a second a while how I remember how to make the CMake. I need to set up this project. We need a docket ignore. I need a src and then include slash Sudokus. Took the liberty and installed that myself. Include directories. Okay. Add executable. I was gonna call it solve src slash cpp. And like this. It's not main, it's solve. Whoops. Is it IO stream? I don't know. I just like don't remember. All right, simple as that. Now I gotta do something. What do I gotta do again? Right, I gotta watch some tutorials on SFML because I have no idea how it works. And my computer's broken. Look at that. No, it's okay. Take your time. It's okay. I don't even care. Okay. SFML. Is it SFML? It is, right? That's what I mean. Yeah. I need like a simple getting started with SFML. I don't need like a giant.
Hello, everybody.
I fear this is going to be a waste of my time.
Hello, everybody, and welcome to another episode.
Okay. Include
SFML tutorial. In this tutorial, I'll explain to you how to create a window in SFML. So first things first, why do we need a window? Well, right now you've probably only been working in a console window, which is this thing that just appeared. So it simply contains text and nothing else, only text. But what if you want something with images? What if you want something to actually show a player character that's moving around or in the world? Well, then we need something different, something that actually can handle images. So for that, SFML has created a render window. SFML has made it really easy for us to create a window and to manage a window. But first things first, the constructor of the window. We're going to call SF, which is the namespace for SFML, and then a render window. We need to give it a name, but just window. And then what you would see is there are 4 different constructor types. The one that we're interested in is the one with SF video mode as first parameter. Let's create an SF video mode. What does the video mode contain? The video mode basically contains the width and the height of the window. Let's specify a width for a window, and let's specify a height for a window. Let's say, for instance, 512 by 512. The next thing that we can give a window is a name, so whatever we want on the top of the screen. So let's give it a name. Let's, for instance, say SFML tutorial. The next thing that we can give it is a style. But what are styles? Well, the styles are basically, if you look at a window, everything that you can see. The minimize button, that's part of the style. The maximize button, part of the style. The close button, part of the style. And even resizing the window is also part of the style. And in SFML, you can modify yourself what you want the user to be able to do. There are a few different styles in SFML. We can see the different styles if we type in SF style. And then inside of this namespace, you have all the different styles that you have. So you have close, so whether or not it has a close button. Default, which is basically a wrapper for close, resize, and title bar. Full screen, so whether or not the window's in full screen mode. None, so basically the window can't do anything. We can't resize it, we can't close it using the X button, and we can maximize it. Resize, so whether or not we should be able to resize our window. A title bar, so if this window should have a title bar. Normally it will always pass in the default, basically close, resize, and title bar. But we can also give it a styles ourselves. So for instance, let's say we only want the player to be able to close the window and see the title bar, but not resize the window because we want to have a specific size for the window. Well, we can do that. Let's actually do that right now. What we need to do is we need to go to this parameter, the third one, which need an SFUN32 style.
Bro, this guy needs to chill, like, you know what I'm saying? Okay. Render window. Video mode. I'm gonna do 500 by 500. Sudoku solver. And then whatever he's about to do right now.
And then we can pass in SF style close. And then using a single strike down, which you might know from the OR, which is a double strike down, we can pass multiple things in as one. This is called a bitwise OR, and I'll explain more about that in my C++ tutorials. And using this, we can also pass in an SF style for title bar. So now,
sure, bro. Let's try that. Style close SF style title bar. Okay.
Now it's time to create a game loop. Since if we now run this code, it will simply open a window and instantly close it because we never specified a game loop. So in order to create a game loop, we need to create a while loop within there, a statement, window that is open.
Simple.
And basically what this will do if you just run it is give us a window that we can't.
The hell?
Move, so I can't move it off of my face. That's because they haven't specified events. Right now I'm just going to step through the basics that we need for the events, and in the next episode I'm going to explain to you what all the different events are. So in order to make it so we can move the window, we need to create another while loop. Within there, window
Can't
that
move the window?
Um,
What? While window.poll event.
And what pull event needs, as you can see,
Oops.
is an SF event. So we need to create an SF event called EVNT, or whatever you want, but don't call it event because event is a reserved keyword. If I just type in event, you will see that it will light up blue. That's because it's already used by C++. So now we can pass in the EVNT, which is an event. And inside of here, there's one thing that we always need to do, is check whether or not we should close the window. Since there's one event that is SF event close, that's basically what we call whenever we hit the X button or hit Alt F4, it's basically whenever we try to close the window. We need to handle it ourselves. So the window won't close automatically, it would just give us a sign like, hey, I want to close, could you please do that for me? So we need to create an if statement. If evnt.type is equal to evnt.close, then what we want to do is we want to call window.close. Now if we run the program again, you will see that we have a window, which is still completely white, that we can move around. So we can drag it around, but we cannot resize it, because we specified that we did not want to resize. We only want to be able to close it and see the title bar. Now let me show you how it...
Yo, this guy needs to chill, bro. I think this is a bug from Ubuntu's part.
It will look if we can resize it, but remove the title bar. In order to do that, we simply remove title bar and change it to resize. So now we're able to resize the window, but we shouldn't be able to see the title bar. Okay, we're still able to see the title bar, but we are now in fact able to resize the window. What you will see is something a little weird with the white box and the black box next to it. That's because we're not clearing the screen, we're not drawing anything to it, so it will always just be the default color. So if we just drag it around, you will see that if we make it smaller, then the white box, which was uncleared before, will now change it to something that is cleared, which is by default a black color. But we're going to learn about that more in a later episode when we're actually going to draw something to the screen. That was basically it for this episode. In the next... Hello everybody and welcome back to another SFML tutorial. In this tutorial,
these tutorials are like 5 minutes long, bro. I can get through like all of these in like a day.
We're going to talk about the different events that you have for the window.
Maybe not
so
today,
the first event
but
we've already sort of covered last episode. That was the event that closed. So whenever
I think I'm gonna watch the. Go a little longer.
hit the X button, it will call this event, and then we need to do something accordingly. The reason that we have to do this manually, so we as programmers have to close the window, is so we can do something like save our game. The second type of event that you have when it comes to the window is a resize event. So an event will be called whenever we resize the window. Let's create another if statement, or actually let's create a switch statement for this. If you don't know what a switch is, I have an episode completely dedicated to functions on my channel, so check that out if you need to know that. So let's just create a switch statement, which contains the event.type. So you want to create a switch about the event.type. And in here, we want to create a case, which is sf event closed. Notice that we can't use event.closed anymore. That's because inside of a switch statement, you can't use parameters from inside of a created class. And since event is a class that we created, we cannot use its internal version of closed. So what we need to do is we need to call closed from the class itself. So sf event closed. And now in here, we can do window close. And if we remove this code, then it will not call it twice. And let's let it break and create a second case. So case sf event.
Wait, chill, bro. Chill. I can't type that fast. You nesting.
And then we need to go down to resized. What we want to do in this case is simply print out whatever the new window size is. So we can do that in two different ways. We can use console out, or we can use printf. I'm going to show you both ways. First things first is include iostream. After we've done that, it's time to call the cout. So std, because it's inside of the std namespace, cout. And then what we need to do is we need to call a parameter inside of the event, which is called size. And basically this is going to be the new size of the window. Size contains two values. As you can see, it contains a height and a width. So what we're going to do is we want to console out the width, and then also console out the height. So event.size.height, then an end line, or an std end line. But if we run this program right now, it will just simply say the numbers next to each other attached. So what we're going to do is we're going to add a little string which says new.
Here's the problem, right? This guy's about to explain to me how to print out the width and the height in C++. Bro, if you don't understand how to do that and you're following this tutorial, you're doing something very wrong.
Window width and then a space.
Thoughts on that?
New window width. And we want to do the same for height. So first the space, because otherwise the other number.
Alright, let's watch this guy cook right now.
Window height. If we run the program, you will see that every time when we resize the window, it will console out the new width and new height. So we can make it really tiny, and what you will see is it will say the exact size of the window, in pixels of course. So let's now use printf. In order to use printf, you need to know the basic functionality. So in order to use printf, we need to call printf, and then in here we need to specify first a string. What the string contains a few special characters. So what we're going to type in here is simply the same that we did here, but the formatting is a bit different. In order to add integers or floats to printf, we need to specify where we want it. So it's not like cout that we simply push all things into after each other in the order that we want. No, with printf, we have a string, and we use some special characters to indicate this is where you want an integer to be, this is where we want a float to be, a boolean, etc. And then we specify those integers and floats later. So we first type in new window width. And now we need to specify an integer because the width is an integer. And the way that we do that is we type into percent then an I for integer. In order to do a float, you type in the F, a char is a C, and a boolean is a B. But we want to use an I for integer, have a space, and then type in a new window height, and then do another %I. And then after this, we need to specify a few more parameters, and that's the width and the height, or the 2 %i's that we made. So event.size.width and event.size.height. So now if we comment out this cout, and we run this program again, and you will see that every time we resize the window, it will look exactly the same in the console. Other than that, I forgot to specify a new line, which I'm going to do right now. In order to use a new line in printf, we can't just simply call std.
I don't. Why are you using printf? Isn't this just a C function? This is like a C function that is like deprecated, not deprecated.
No, what we need
but...
to do is we need to use the character for endline, which is /n. But make sure that you use this slash, so the one that's above the return key. And if we run the program again,
why am I using
we'll see
printf?
that if you resize
Why would I do
right
that?
now, it will actually show it on the new line. That's basically all I have to say today. In the next episode,
You didn't teach me anything. This guy. Text event.
Hello everybody, and welcome to another SFML tutorial. In this tutorial, we're going to learn how to get user input and print it out to the screen. But first, why do we need to get text from the player? Well,
Dude,
for
I
instance,
used to have this snowball right here. This. Hold on. We getting distracted real quick. Oh, my internet decided to stop working. Am I still recording? Hello?
I want to make it so the player can enter his name, and in order to do that, we need to add another case to our switch. And the case that we want to add is called sf event text entered. And basically what this does is it will check if there's text entered, and it will do it in the same way that it will do in a text editor. So if you hold a key, it will go slowly, wait for a while, and then go fast.
Yo, okay. Chrome. Dude, I used to... shit. I used to have this one right here, the one he has, and I had carpet in my house. Dude, I swear to God, like, I have never been shocked so much. Like I swear, like there was a lightning storm in my room every time I came close to this thing. Terrible.
Faster. And you can use the control keys, you can use the shift
No, like,
key.
because I would come back from school, and I remember, like, I'm like, okay, I'm going to sit down at my desk, and I would touch it with the palm of my hand every time, and it would still hurt. It's fucking funny.
To make capital letters, for instance, it's basically to use the text entered event, then in order to make your own system for it. So in order to actually show something on the screen, it's actually not that difficult. The only thing that we need to do is we need to type in printf, and then in here, simply a %c. So a character, we only want to print out one character, and the character that we want to print out is inside of the EVNT. So
Dude, I want to draw shit to the screen, dog.
The text, the Unicode.
Unicode.
And
Dope.
one thing that might happen is that a character is going to be some sort of control character, or it's going to be bigger than everything that ASCII handles, and I don't want that. So what I'm going to do is I'm going to add a simple if statement. So if EVNT, the text, the Unicode, is less than 128, since that's the range for ASCII, we will printf the character. So now if we run this program, you will see that whenever we hit a key on the keyboard, it will actually print it out. And the one funny thing, the backspace key is actually also working, but the only thing that's happening is it doesn't update it automatically. But if I now type, you will see that it will overwrite. So if you just type a whole lot of W's, then go back a few steps, press a whole lot of A's, you will see that it overwrites. So this is how you get text input from the player, since you can also use the shift keys and the control keys and the alt keys, and will all give us valid characters. And if we hold a key, then what you will see, it will first only give you a single version, and then it will continuously add the key. But let's say, for instance, we want a character to move, and we don't want him to, like, if you hold the A key, then it will take a step, then wait a second, and then continue walking. What we want is that it constantly keeps walking fluently. And the way that we do that is we use something different than events. So we're going to talk about that in a later episode. This is basically all that I have to say today. So thanks for watching. I'll see you in the next one. Hello everybody, and welcome back to another SFML tutorial. In this tutorial, I'm going to explain to you how to draw.
Oh, my cam was blocking his cam this whole time. Doug Trio can stay there. Oops.
Cube to the screen. So first of all, why do we need cubes? Well, cubes are the easiest shapes to work with, since we can specify a size simply by giving a width and a height, and then we can give it a texture.
A what?
Using transparency, we can actually make it. Cubes are the easiest shapes to work with, since we can specify a size simply by giving a width and a height, and then we can give it a texture. And using transparency, we can actually make it whatever shape we want. So we can add a character on there and only like give it a human shape, or we can add a circle on there. So how do we actually create?
That's not sounding like a cube, bro. That sounded like a square.
Rectangle shape.
Okay, that's all. Definitely not a cube, dog, but it's
So
all
now it's
good.
time to give it a name. So let's call it player, since we're later going to move it around. So now as parameters in the constructor, we can give it a size. And a size in this case is specified as a vector 2f. So what is a vector? It basically contains an x coordinate and a y coordinate, and that's it. So in this case, we can use it for width and height. You can do way more complex things with vectors, but we're not going to talk about those things right now since they're not important yet. So let's create an SF vector 2f. It's important that we create a vector 2f, which stands for float. You also have a vector 2i, which stands for integer, and vector 2u, which stands for unsigned integer. But never create a vector 2. A vector 2 basically doesn't contain any type yet. We need to specify whatever type we want it to be. So SFML made it easy for us and gave us a float, integer, and an unsigned integer. So now that we've created a vector 2f, we need to give it two different values inside of the constructor, the width of a character and the height of a character. So let's just create a character with the size of 100 by 100. So now it's time to draw the character. How do we draw in SFML? Well, drawing things is actually pretty easy. What we simply need to call is window, since we want to draw to the window, and draw. And then we specify what we want to draw in here. So I'm just, in this case, just player. And now in order to actually display it, so in order to push all the different draw things that we called to the screen, we need to call window.display. The way that most games nowadays print to the screen is using two different buffers. So basically, inside of the computer, you have two different screens that you print to. Your front buffer and you have your back buffer. The first thing that you're going to do is you're going to print to the back buffer. So everything that you want to draw, you draw on the back buffer. And then whenever you call display, you're going to swap them around. So what used to be the back buffer is now the front buffer, and what used to be the front buffer is now the back buffer. So now you draw to what used to be the front buffer. And then when you call display again, you swap them around again.
Bro.
So you constantly keep doing that for every frame, and that way you will never have some weird problems that you can have if an image is not completely drawn yet when you try to display it. So now if you run the program again, you will see that we have the little white box on side of our black screen. We can actually change the color of the box pretty easily, so let's do that right now. Up here, where we created a rectangle, we can call a little function.
Alright, let me draw this little square and I'll be done for the day. Okay, what is it? Do I gotta move my cam now? I'm gonna move my cam. Alright. Ren. What is it? Rectangle shape. Player. Just a player. Oh man. .23 enum value is not handled. Okay. So hold on, you're telling me it's easier to just like do like this? Hold on. Oh, I guess I don't actually need this here. I do a there it is. Boom.
So if you type in player dot set fill color, we can change the color that is printed in it. So we need to give it an SF color, and if you go a step deeper with SF color, you can see that I've pre-made a few colors for you. So black, blue, cyan, green, magenta, red, white, yellow, and transparent. So let's say you want to create a red cube, then we just simply type in red, and that will do it. If we run the program again, you will see that the cube is now red. It's that easy. That's basically all I want to talk about today. In the next.
All right, it's gonna be for me today. Tomorrow I just need to make the grid. Make the grid, and then I'll be chilling. Yep. Oops. Origin. Oof. Oh. Yeah, bro, it's good. All right. Peace.